Hello, everybody. John, you're making a lot of. You look like
Just kidding. I was
uh,
messing with you.
he's messing with
Yeah.
us because we just spent the last 15 minutes trying to get his audio working because he just
Yeah.
sounded like he was a bee in a tin can over there. And
And you were blaming it all on me
yeah, of course
with
we were.
this.
And then someone leant over and put their finger in the vicinity of this and didn't touch it, and then it all worked. So
So
we're not.
I want it on record. It wasn't my fault.
Well, we don't know that for sure. Quantum entanglement is a thing, John.
All right. Oh,
So,
no, we're going to quantum effects.
yeah,
I don't
yeah.
know.
How are you?
Good. I'm good. I'm happy because I've been chasing Sébastien down all summer for a show, and this is perfect timing.
Perfect timing.
Last time was
Uh,
a year ago. Well,
it's been far too long.
Excellent.
Yeah. Well, and Damien, it's awesome to have you on regularly again.
Well,
This is-
2 weeks in a row counts for regularly now. So
That's I have low standards.
even if we don't have Hanselman, I think Hanselman is camping this week, so
He
he's not,
is camping.
he's off doing something he loves dearly, which is camping.
Yeah, it sounded like he could not wait to get out.
I think he and I both share a shared love for camping.
Yeah.
So anyway, I'm assuming that you love the community, John.
I continue to love the community.
You have lots of community-focused things to share with us.
I certainly do.
Woo,
All right,
okay.
ready?
Yeah.
So here we go. First of all, this is quite a long post. This is a nice one talking about Selenium, setting up Selenium build agents for Azure DevOps on both Windows and Ubuntu. So, this is you can see from my scroll bar here. This is a couple of cups of coffee post.
Holy moly.
Yeah, but so some of the things that are nice in here, talking about, you can set them up classic or via YAML. There's also explaining some stuff, like there's a walkthrough of setting up build agents both in Windows and Ubuntu.
Okay.
And as I was going through, this is going through, and I was thinking potentially it'd be setting things up via Docker image. This is just doing a wget on like invoke web request and pulling down the WebDriver on an existing build agent. And then one thing, I thought I had a little gotcha here, because he goes through and he explains here's how to set it up on Windows, and then he goes through on Ubuntu and is doing Ubuntu bash kinds of things. And I'm like, wait a minute, you could have used PowerShell. And then yes, he also gets to that you can, because the Azure build agent comes with PowerShell core installed. And PowerShell's cross-platform, and things are crazy now. So going through and using, quite a lot there.
Very good.
Good stuff. All right, Chris Saney has been doing some cool blog posts lately on Blazor. This is one on drag and drop with Blazor. I love this, the kind of Kanban style board. So starting by looking at what's in the HTML5 spec. But then also showing the kind of wrapper, the API around it in Blazor, which is cool. I hadn't looked at that, honestly.
Wow.
So that is neat.
When you say in Blazor, you mean he got a package from somewhere in the community, or?
So it says here, Blazor has C# representations for the drag and drop API.
We do? Built in? Wow.
It's in a blog
It must
post.
be because it's one of the core. I mean, because we don't map every browser API by default. You typically bring in a wrapping package that uses the JS interrupt to do so. So we have UI drag event args out of the box.
Yeah,
that's
sure
amazing.
looks like.
Okay.
Isn't that cool? Yeah. So, and then, because of that, building out this thing is actually not a huge amount of code. Handling the handle drag, handle drop, that kind of stuff. So, yeah, so very cool. All right, DotyG, who you may remember has his practical ASP.NET Core. He has hundreds of samples. He keeps them updated. You can see this one updated 9 hours ago. And so what's nice here is these are for all different, for 2.1, 2.2, 3.0 now. So this one I thought was interesting. This is GRPC server-side streaming. So setting this up using in the middleware here, or just basically running a loop, and it's just writing out hello, and it just writes it out continually. And then in the client, it's just handling the GRPC stream response. So
cool.
Yeah, one thing I like about Doty's samples is they're very lightweight. Like, so sometimes you'll see a sample and it's mixing a bunch of different stuff together. And these are great from the point of view of, I want to learn just one thing at a time. And this shows how to do that. So this is the client side. So he's got a client and a server talking gRPC to each other.
Nice. We saw a demo. Actually, we just had an all hands meeting.
A race meeting.
For the ASPNET team we just came from before this, and James Newton King dialed in from New Zealand and gave a demo of exactly this. It was server-side, client-side gRPC streaming while observing the current metrics of what's going on in another window using the new stuff in Preview 8. Which lets you get said metrics for gRPC. And he'd set it up as a race, so the connection got established from the client to the server. It invokes a method, and then both the client and the server, because you can do duplex streaming in gRPC, basically send each other messages as fast as they can over a fixed time period. So like, right, 30 seconds, go. And they both sent as many messages as they could, and we all bet on who we thought was going to send more messages, the server or the client. And of course, we know which one it was. We all know which one it was, don't we? No? You're not going to? Okay.
I'm guessing the server.
The server managed to send more messages to the client than the client managed to send to the server.
All right. Cool. All right. Jürgen writing up a post here on just a quick look at a difference in startup CS. And really here what he's pointing out is the app.use routing. And this is kind of the, like the endpoint routing, and this is configuring app use routing in the startup. So just talking about what's different there. Honestly, a lot of time, like there's stuff changing all the time. And I was kind of like, wait, when was this added? Was this possibly in 2.2?
No.
And so I actually went out and I'm calling this out as a separate link for this week. The migration docs are really helpful for this kind of stuff.
And we do update them with every preview. Yes. So they got updated this morning.
So this is, so this, for instance here, use routing and, there it is. And so this is, like you said, this is a great resource. And I think people don't pay enough attention to these, like how often these are updated. Like you said, updated this morning, and it's like all the good stuff. So, yep. Cool. Another neat thing. This is the ASPNET Core Facebook group. This is just a publicly
that's good. A minute there I thought you just accidentally switch over to your Facebook page and we were going to start looking at your social life on
okay. No social life for me.
Okay.
These are my friends. But this is pretty cool. This is 10,000 people are on here, and there's tons of links coming through, a lot of activity.
Which group is this? Sorry, this isn't the .NET group. This is ASPNET Core.
This is just a community run thing.
I'm going to go and join this group right now.
Yeah, this is, and so for instance, and this, I should have looked here before I got my links together, because here's Doty's link. There's some of the others that I've shared. Here's that drag and drop. Yeah, a lot of good stuff. So you don't need me anymore. And these people, look.
It sent a request. It says I have to be approved. So
whoever
runs that group, 10,289 members, my membership is pending approval. I'll understand if you don't let me in, but I'd love to be part of your group.
Yeah, so good stuff. All right, one last link I wanted to share, and this is, a little bit apropos of maybe what you'll be talking about, performance of the actual framework. But this is another great resource that I think people forget about, is there's prescriptive guidance. Like the docs aren't just going to tell you what is the API or how to write middleware or something. We'll actually recommend things to write better apps. And so these are ASP.NET Core performance best practices. And a lot of this, this is, there's community pull requests in here. There's updates in here as the platform changes, and just all kinds of good stuff. And then this drills deeper into stuff like, okay, see more about garbage collection performance or caching, how to cache, and then actually linking you through into, here's the guidance and then here's how to do it.
Yeah, and that doc was originally written by a principal engineer here at Microsoft who actually works on our customer and partner engagement team. So he spends all his time working with real-world customers who are migrating, typically large enterprise customers, but not always, who are migrating their apps to ASP.NET Core. And this was based on what he had seen and what he had experienced in actually doing that type of work with customers. So shout out to Mike there, who he actually approached us and said, do you think this would be interesting if I put this article together? for docs, and we were like, yeah, I think so. So yeah, looks like it's been a bunch of folks have contributed to it since then too. So.
Yeah, very cool. And like I said, this is a high level overview, and then it digs down deep into some other stuff in here. So it's really good. Like you said, it's people that have done this, and it's guidance based on the real world stuff.
Very good.
Cool. And as always, I'll be sharing out this link, and that's it. I'm done. So I'm going to stop the sharing.
Nice.
Back to you.
Well, Seb has gone to a lot of trouble to prepare.
Nope.
I can't even come up with the words to express what today is going to be like. It is chock full. It is jammed full. It is to the brim with performance update goodness.
No, we went through a lot of trouble, but not to prepare.
Oh. We just a lot of trouble. The word trouble is true.
Yeah.
Can we try moving your mic slightly closer? Can we maybe put it here? Thank you. There we go. That should be better, I think.
Let's try again.
There we go.
Thank you.
Excellent.
Okay. Are you sharing my screen?
I can do so right now. Are you ready? Are you ready for me to do it?
Sure, I want.
You ready? You sure?
Can I?
Okay, there it is.
Yeah, so we wanted to give an update on the perf work we've been doing and perf results also to let the community know about the improvements that we are shipping with 3.0 and also all the stuff we've been working on.
Segue, quick tangent on that.
Yep.
Preview 8 is out today. We didn't really give it the fanfare it deserved, and John missed it in his community links. He usually would put the release blog post there.
Sorry about that.
So if you go to the .NET blog and the ASPNET blog, you'll see a number of posts today. Preview 8 is now available, as I said in last week's stand-up. Preview 8 is a go-live release like Preview 7. It's the new ones, a bunch of bug fixes in it. There's some new APIs and last-minute API changes that are coming through, especially for things like Blazor and EF Core, which had a known body of work that was happening towards the end of the release. And I also said, if you are really, really waiting for what you want, like a true RC, Damien, give me the real release candidate. Preview 9 is the one I would wait for, because there's still a body of work that will be happening in Preview 9. Someone's asking, does Damien have double the loudness? No, I'm just a lot closer to the microphone than everyone else. And I'm projecting my voice, whereas Seb is.
Well, fortunately, a nice feature of the URL list is that I can update the link. So I included that post.
Yeah. So if you want to remember, because of the changes that we shipped in .NET Core 3 Preview 7 with regards to how it works with Visual Studio, if you're just using Visual Studio 16.3 Preview, which you should be if you're on Windows and you're doing Visual Studio development with .NET Core, because you need to be using the preview, it includes .NET Core 3. You don't have to do anything. Just update the preview channel and you'll get the latest stuff. And you can go and download the SDK separately, which is what Seb is showing right now, from the SDK download page. Okay, and then you can do that as well as getting the one inside. It's totally fine. Or if you're using VS Code, you would go and download, or a different editor, you would go and download the SDK separately, like you have been used to doing. But if you're on the preview channel for VS, which we talked a little bit about last week, just update it today. There's a new version today. I guess it's 16.3 Preview 2. I think I got that right. I think it's Preview 2. Which includes 3.0 Preview 8 of .NET Core 3. So go and check that out. And the blog post covers a bunch of changes that are in Preview 8. So right, back off the tangent, back into performance.
Into performance, Preview 8 is not faster than Preview 7, but Preview 9 will be faster than Preview.
All right, Preview 9, performance improvements coming only because we made a regression in Preview 7. We slowed something down, and we're now finally going to get to fix it in Preview 9. I spoiled it for you.
We'll show it. It will be a nice thing, and you will learn something.
Awesome. Awesome. I always like to learn things.
So yeah, we'll talk about the new things in perf. I have lots of talking points. It could take 5 minutes, like 5 hours. We'll see. Maybe you don't remember, last year I did the same presentation in August also, and I demonstrated how we were measuring the benchmarks and refresh.
We should go and find that show link. I'll do that, and then I'll put it into the chat. You found it?
It's on 28th of August 2018.
Ooh.
So how do I do that?
So I would go to live, go scroll to the bottom and go see more episodes.
See more.
That takes you to the playlist, and then scroll down in there.
I search for Sébastien.
and then there I have all the dates.
I was wondering, why did I show last time? I'm like,
there it is. It's episode number 32. It's actually not number 32 because it's backwards reverse order in the playlist. So it's it's 200 and something. It's 100. It's episode something. But there it is.
Yeah.
Yeah. So that's how you find it. If you want to see the previous one. Cool. So this is an update.
Yeah. What did I show? Like, did you know about that? Yes. So, so we have a bunch of services that can run on machines that will let us benchmark applications, anything, and we use these services to measure our perf continuously and chart the results. Okay? If you want to see all these graphs, the actual URL for the public is aka/ms/ASPNET/benchmarks, and then you get access to these charts. We just have more power because we are inside Microsoft, so we have a different menu, but this will be the same thing. And this first page shows all the Tech Empower benchmarks that we're measuring, either on Linux, Windows, or ARM in the cloud, on Azure, and on the physical infrastructure. So the physical infrastructure is replica of what Tech Empower is using. The same machines exactly, same network card, same switch, same servers, and the cloud is Azure VMs, the same thing that Tech Empower is using. Okay? And this way we can see the changes live while we do changes on ASP.NET and the core effects and the core CLR.
So which version is this tracking?
So this is the 3.0 -star branch. Okay, and this is to see what we are doing continuously until we start working on the next version after 3.0, and then you track the next new thing. And we see here some variations of plain text, some variations of JSON, of data updates that uses EF, Dapper, Radio.NET, Fortunes, and database stuff. Okay, but usually we don't really look at this because there are lots of data, but we can see some trends. That's interesting. And you can see like, oh, it's going down. What's happening? Well, it took us a month to figure out what was happening. And by chance, we figured out. But that's part of another chapter. We can also see some things jumping. Oh, what's happening? Like that? That's good, right? But we'll see why it's not that as good as a jump. And we can see also here some drops, some big jumps here, and I will explain you what happened and why that happened. So on this page we have Tech Emperors, but the two big interesting things I think are the custom page, where you can follow every single benchmark individually or by being able to compare them. Like in this case, I selected this one, but let's say we look at the plain text, is the most famous one, that is the fastest. We can see here with that filters that we can compare Linux and Windows concurrently. So they are the two same physical machines, and we run the benchmarks on the two machines and we graph them. So we can see the evolution of the differences between the two. And with that, we can also check on cloud, on ARM, and we can also compare two different benchmarks. Like if I hit Control and another one, and I can then focus on a single OS and see the difference between plain text and plain text non-pipeline. Okay, so you can compare two scenarios if you want. Like, so that is useful. And what's also very useful for us is that we can track many metrics, like the time to first response, which is very important for starting up applications, is split into two different numbers. The blue / greenish one, turquoise one, is the startup time of the application. So the time from starting the process to the server is available. And the gray part is the first request. So when you issue the first request to the web server, there will be some initialization like DI, middleware pipeline, and everything that needs to be done first or once. And this is the cost of the first request. And then the later requests are tracked by the latency, either on load, which is what is shown here, or not on load, which is not displayed in this graph, but we have the data also. We can track the CPU, the number of bad responses or socket errors, and then what is very new for us since a few months ago are all these metrics like GC metrics, so Gen 0 GC numbers, average per second of collections. We can track the size of the GC heaps, Gen 0, Gen 1, Gen 2, and large object heap, the size of the full GC heap, and the allocation rate. How much allocation do we do per second on average? On average, meaning that when we do a run, it runs for 15 seconds. So this is the average allocation rate for these 15 seconds. The time in GC, the log contention, the exceptions, the thread pool threads, the queue length of the thread pool, and the thread pool items.
The folks who have been doing .NET for a while may be used to tracking some of these things in Windows performance counters.
Right. But these ones are .NET counters,
right,
which is new in 3.0 something, and they are super useful. These are the, how to call it, the CLR maybe? CLR .NET counters?
Yeah, the runtime counters.
The runtime counters. And there are some in ASPNET also, and now in GRPC.
GRPC,
so anyone can provide .NET counters. What I like about them is that they are super they have no impact on your application in terms of perf. I measured with and without. They don't cost anything, or nothing
very
that
low
you can
overhead,
measure.
right?
So even our plain text numbers, which are the fastest we can get, we didn't see any change in the numbers by enabling that. So what we do now is we just enable that all the time and we track them. They are super useful. And also what is super interesting also is that the counters can be tracked out of process. So you don't need to run the code in the app. You can connect using name pipes to the process, to a different process, and get all these metrics outside of your main app. So that allows for making sidecar apps that you could run aside your application to track all these numbers live and store them, or just show them in a graph if you want, as a side app. So let's say so that's super useful if you want to create your own metrics application to track your application.
And there has been a blog post on this stuff, if you haven't seen it already. Saurabh published a blog post to the ASPNET blog, I think, or .NET blog, one of them, about this around preview 6 or 7 timeframe, using the new .NET counters tool and to do that.
Yeah, there are tools for that, and you can also build your own. That's what we did. We used the API that is also available on NuGet to connect to these .NET counters and track.
Right.
So these are super useful. So that's what I wanted to mention about the new thing. We have also these KPIs Windows Linux. I will open this one. And this is what is always displayed in Damian's office. So people usually track their stocks market every morning. They are like, is my stock better, green, red, orange, whatever? But Damian tracks those ones. Maybe he also tracks his stocks, I don't know. But
set and forget. Not for these things though. I need to know every day. First thing I do when I put my bag down in the morning before I take my laptop out, I turn on the screen on the dashboard and I look at these numbers, decide if it's going to be a good day or a bad day.
And sometimes Damian shows up in my office.
And then, if it's a bad day, then I show up in Seb's office and go, what happened here?
Let me explain.
But it's good to see that there's a lot less red than there has
so last year we had like 10 numbers in the KPI. I remember, so I saw the video just to see what we showed last year. Now we have like hundreds, and that's an issue because super slow. Every little widget here is a node service on the server side that has to return something. So it's super slow for us. So we had to split it in Linux and Windows. We can't have them both on the same page. But so what we track is the trend over 3 days of each major benchmark that we see here. The trend over 10 days to see if there is a slow regression over 10 days. There is one here. We have to check. And then we track also, we used to track the servicing risk, but we have a technical issue right now. We track the latency, same thing. We track the changes in RPS from 3.0 to 2.2. So we can compare what will be shipped in 3.0 versus what is shipped right now in 2.2 in terms of RPS, in terms of latency, memory usage, startup time. Okay, startup including here the first response.
So someone's just saying, sorry guys, I'm completely lost. And does this mean that .NET Core 3 has better performance? So they really only turned up to get one piece of information, it turns out, and they just want to know if we're faster. The short answer is yes. If I might take if you go back to the KPIs for a second, can we look at the KPI dashboard without all the Chrome? Just a little. Is there a way that you could zoom that in?
That's what I did here.
Okay, but that has all the OneNote Chrome instead. It's very distracting.
But it's just the data you want to see here. This is Linux.
So
and just
the way to read this, the KPI chart, is vertically every column is a different scenario. Okay, so we've got plain text as the left-hand most, then JSON, plain text non-pipeline, MVC plain text, etc., etc., etc. The horizontal lines represent either measures over a different time period, so RPS, as Sébastien said, averaged over the last 3 days, RPS over the last 10 days, or a measure of a different thing. So latency, again, over the last 3 days, 10 days, or versus the previous release. Startup time in milliseconds, the working set of the process, etc., etc. And so this layout allows someone to look at this very, very quickly, and with the top left-hand box being the most sensitive test, which is the plain text test, which is our highest number with regards to RPS over the last 3 days, and C is, are we trending in the right direction? The reason we break down over 3 days and 10 days is because you want to be, as Sébastien said before, you want to know if there's a difference between within a tolerance, because there's always jitter within the environment. Are we going down slowly over time? These sudden drops we'll see very easily. Or is it something that is going to happen quite suddenly? And so by having that differential between 3 days, 10 days, and the last GA release, we can very quickly look at the comparison. The third row here is the one that most folks tend to be interested in, which is how fast are we compared to the last release, which was 2.2. Now you have to zoom in to see the 2.2 number. It is there because this is designed to be, I view this on a 75-inch TV in my office. So that's what Sebastian's done here. And so you should see that one there. So we're 4.2 million was the last Linux number we get for full. This is not plain text platform. This is full ASPNET core running through middleware. This is real middleware stuff. And then the 2.2 number, which is underneath that, which I can't see.
I can. 3.05
is 3.05. So we've gone from about 3 million to 4.2 million.
Almost 40% improvement. Yeah. So this is on Linux. So we have the numbers for Linux and Windows. On Linux, we jump from 40% improvement on plain text, 16% improvement on JSON, 12%, 42% on basic plain text. Endpoint routing, we don't have jumps because it wasn't available in 2.2.
Right.
But we have the numbers for 3.0. And the numbers for 3.0, if I check here on the last release, 3.5 million out of 4.2 for middleware without any routing. This one has routing. And you see 8% on Fortune's ADO.NET, 15% or 14% on HTTPS traffic plus 29%, and JSON HTTPS plus 20%. So these are all good numbers. And then latency goes down, for instance, on plain text, minus 96%. Doesn't mean anything. It's from 24 milliseconds to 1 millisecond. The issue with latency is that depending on the load you send, you can have very bad latency or very good latency. So this is the highest throughput that WRK will send. So this is meaningful for us, but it depends on each payload.
That's a huge change, that latency there.
Yeah,
wow.
It depends on the load. So that I will not. It's important, but this one really depends on what you're doing on your server.
And the latency number we always take with a massive, massive, massive grain of salt. But that is, apples to apples. It's using the same client load server, same tool. And
so what's important here is that these numbers are run side by side. So what we do is we run the numbers 3 times with the 2.2 framework. And then right after that, we use the same scenario on the 3.0 framework. So they are time constrained. It's not like, oh, we run it one day and the other one the day after. No, they are very close, so we don't pay for any physical issue or connection, or we never know, or patch applied or whatever. So these are very important, and they are stable. So we run them 3 times, so we have a stable number that we can trust. You mentioned that latency was very good. I agree, but what's more important here is memory. Look at that. If we take an app on 2.2, the plain text app, so it's just a middleware that returns hello world. On these kind of machines, because this is very important here, it will take 1 gigabyte of memory of working set. Okay? But with 3.0, it's taking 76 megabytes of memory, minus 93%. And this is the cost of the framework itself. So the idea is that your app will still take some memory because it uses memory. But the framework itself won't take as much memory as it's used to have. And the idea is that the GC team made some changes in terms of how much GC heaps were allocated by default per core. And the numbers they were using were kind of old, based on old process infrastructure that had much less cores than what we have today. And the numbers were out of date. So they changed how they are allocating the GC heap by default. And now it's taking much less memory by default. So you see the difference on the plain text. Same thing on JSON. JSON is much allocating. So the 407 you see, so you see here the 1.8 before, the same as plain text. It means it was committing some memory more than it needed. Now it's committing less and committing as you need it. So in this case, JSON is allocating, so we have 400 megabyte allocated in the committed memory, but much lesser than the 1 gigabit that you needed before.
Wow.
And all the numbers are the same. You see -60%, -93%. And we go over all the scenarios, they will take much lesser memory. So that's just benefit. And this is a machine with 28 virtual cores. So the more cores you have, the bigger the improvement will be. So for, I remember the first discussion we had about that was, I think, from Nick Raver from Stack Overflow. They had something like 60 cores on their machine or something. No, maybe the same amount of cores, but they also had a lot of memory. And a simple console app was taking 2 or 3 gigabytes of memory. And they were like, what is that? Because I need to start 10 apps like this. Why are they all taking 3 gigabytes? They are doing nothing. They should not need that. And that was that. So now they should be much better with you.
Well, there was a little more context to Nick's complaint at the time too, I believe, which was they had ported a .NET Framework console application, which would have been using Workstation GC, over to .NET Core, but they were using the Web SDK in the new project, which changes to Server GC by default. And so they inadvertently had changed from Workstation GC to Server GC, and the behaviors that Seb was talking about with regards to what's changed in 3.0 all pertain to Server GC. And so Server GC used to be incredibly aggressive about how much memory it would allocate or reserve, and that's gone down drastically in 3.0. Which is great.
So in the past, it needed to reserve more memory because just everything
it wasn't
used
need,
more memory.
It was just it was the algorithm used by the runtime to pre-reserve sort of the amount of space it was going to use was based on a tweak made a long time ago when like dual core processors became more popular.
Oh.
Yeah, so like it was something along those lines. It had not really been looked at in a very, very long time. So the change itself was actually very small. And then we also added new knobs so that you can go in and change a bunch of those limits. And so because what happens is, the runtime boots up and says, oh, I need 400 megabytes of reserve space in order to create my GC heaps. But then it divides that by the number of logical CPUs available on the system. And on a server like this one, where you've got 28 logical CPUs, because it's 14 core with hyperthreading, it would then literally try and create 400 megabytes divided by 28 size heap on every single CPU, which was pointless if you weren't ever going to be using a highly multi-threaded environment, or if the I/O load or the workload was such that you really didn't need that much heap fragmentation or parallelization, I should say. Server GC does that by design because you want a heap per CPU so you can get the efficiencies of doing so. But doing that straight off the bat, especially for low memory limits where you want to start up not with 2 gigabytes of memory, but you just want to use 100, why split 100 over 16 or 28 cores? That doesn't make any sense, right? And so that was really the big change. And so because the plain text test in 3.0, as Sébastien said, is basically non-allocating once the connections connect, and we only use, 76 megabytes of working set for the entire process for running the millions and millions of requests that go through that. Why reserve the 1.5 gigabyte that it used to? It doesn't need to. So obviously that algorithm seems much improved, at least for the workloads that we've been testing, and we haven't had any complaints yet. So fingers crossed it's going to work out well for most people.
Yeah, that and all the new knobs that you can configure the limits and when to GC and when to stop allocating. So, and also the idea is that if you have 64 gig of memory, well, it's okay to reserve 1 gig. You have lots of memory still available, but now that has changed. And the startup time also very, very much improved by 50% on all scenarios, even on the slowest one, which is based on EF, because EF is a big element to JIT, and still 45% improvements in startup time. And these are mostly also due to tiered JITting, which is on by default in 3.0.
So that's something which was available previously, but it was off by default.
That's right, it was opt-in previously.
And the same numbers on Windows. Some of these are not as important as Linux, but you get the same benefits. And look, even the memory on Windows for plain text is 53 megabytes. And
so what's the difference between why bigger gains for Linux versus Windows? Was it coming down to?
Because I have a tab here with
Linux
okay. Because there was a lot of work on Linux specific issues, because with this benchmark you can see explicitly the differences between Windows and Linux. Our devs, they don't have both boxes available to benchmark this, and they usually, most of them use Windows, and it's harder to then benchmark on Linux because I've set a VM and you don't see it obviously. And with this benchmark it's much more obvious. So what I've been doing, and I will jump directly to that, is that when I found some issues differently between Linux and Windows, I will file issues, and this one is typical. This one, okay. I filed this issue. That's my job, filing issues, okay. And so I said, why is that thing slower on Linux than Windows? And explaining the scenario, and with our tool we can also take traces that like share with the devs, give them all the proof that there is an issue, and then people cared and are like, okay, so Adam Sitnik, who you all know because he's working on benchmark.net and other things, decided to track that and found the reason and found the fix and fixed it. Okay, and then he used the same thing to show the improvements, like before, after. I can't find it, sorry. At some point I will. And yeah, he's like, oh look, now we have the same numbers on Windows and Linux. It's awesome. Like from 20,000 to 110,000. And then with his change, I could repro and say, okay, it's fixed, done, it's merged. And look at that, before 40,000 requests per second on a specific scenario, after 240 requests per second, just trying to pinpoint this specific issue for this specific code. And why I filed that, this environment culture in our case, it's because we were looking at the data updates taken per benchmark. And if I go back on the data updates taken per benchmark, which I will select from this tab, you will obviously see the issue. So data updates, multi-update, Dapper. And if I compare to multi-update raw, because Dapper is kind of raw, is that the one? That's not the one I want, or maybe it's not that old. Interesting. Why is that? Let me check. But I have it on the, yes, this one. Okay. So look at before this jump. Okay. Here, super slow, Dapper, like, let me see, 2,000 requests per second, something like that. And here, 13,000 requests per second for the ADO.NET. So this is ADO.NET. The top is ADO.NET. And this is Dapper doing lots of updates. This is the Tech Emperor benchmark. And it has always been super slow. Even Ben Adams could not make it faster. Why is that? So I found the issue that was this thing, an invariant culture comparison on Linux. And then this is when the fix got merged in CoreFX. So that was it. That solved the issue. There was 2 or 3 attempts to fix some things with the GC, but then this one fixed everything. That was really the goal of fixing that. And I remember I'd even mentioned that issue to Mark Gravel when he was at the MVC Summit, that there was an issue with Dapper. But the issue was not really with Dapper. The issue was triggered by Dapper because it does some specific lookups in a dictionary to find cached types or SQL queries, I don't remember, which itself, or parameters, which itself delegated to the benchmark driver, to the ADO.NET driver, sorry, which is in this case NPG SQL. And that's where everything went bad, because also NPG SQL has big connections, of caches, and that was triggering a big issue. So it has been fixed, and now this is...
How is it that ADO.NET is now slower than Dapper?
So this
seems impossible.
No, look at that. So this happened on the 1st of August. This is the next chapter we have to talk about.
Okay.
So...
Interesting.
It's weird, but Dapper does some caches, maybe that, I don't know, I have to check. But,
okay.
But there are big things happen here. So this change, you see, this is on the 19th of June, and the fix was merged around that. Okay, this is when I figured out it was together. And not only that, but if I take another benchmark like the HTTP client factory, which is just a measurement of HTTP client performance, on the 19th of June, boom, look at that. So this is Linux. This is like 127,000 requests per second. That goes to 193. This scenario is about creating concurrent connections to a proxy server. So it's like a proxy, it's a proxy server that is evaluated to see how many requests we can forward to other servers. It's like a microservice benchmark to benchmark the HTTP client itself. And HTTP client or HTTP client factory are the same scenarios. But on Linux, this is the jump that went in, okay? Just because of that. And this you'll get on 3.0. So that's one improvement also because of that. And there were others. So that's why Linux got much faster in terms of differences between 2.2 and 3.0 for small improvements.
It's really interesting. I've been looking at the actual files changed and stuff, and it's like it comes down to, I mean, of course it would have to, but it comes down to native implementations. And like you said, it's stuff like deep in the like globalization classes and stuff like that. So by your filing these bugs, they fix these benchmarks, but they fix stuff all throughout the stack as well. Like anyone that's using this, in this case, like ref counting with globalization, it helps everybody. Yeah. That's really cool.
Yeah, that's very good. So sometimes we just have the issues, but we need to find someone to be able to fix it. Just availability of all the devs and the importance of the ref impact. And maybe it also fixed some other things. HTTP client connection close also. It also improved the connection close scenario, which is when we actually don't keep the connection open. We just recreate many connections as fast as we can, and then it improved that. Yeah, so Linux that. Also, Adam has been working on a new template for benchmark infrastructure that the CoreFX developers, so because of his work, is like, we need to use these services to test concurrent access. So the issue was some locking contention in the environment culture in your case. There was a lock somehow. And we could only see the perf impact on ASP.NET because that's where we do benchmark with concurrent loads and where the locking will be will have a big impact on the perf. When you use benchmark.NET, you find a raw perf, but it's harder to find bottlenecks in terms of contention. So what Adam has been doing is a simple template on our repo that any dev who cares about lock contention can clone and run our infrastructure on. And what the dev will do is just replace this code, which is just a sample, by the code they want to measure. And then they will be able to get performance on ASP.NET for this specific piece of code. Okay? And this is actually another concrete example he's been working on with this specific crypto API that had some perf issues, and he's been working on and using this sample to measure the impact on the concurrent load and to see if it's faster. Yeah, that's what he's doing also. So he's trying to improve the infrastructure also to make it simpler for devs, CoreFX dev in particular, to make faster code on ASP.NET. Another thing that has been we have on the Linux part is Tom Dyson is working on a Linux transport for Kestrel that is optimized for Linux, and that's where we get the best values on Tech Empower. So if I look at
I've shared his a couple of times, or at least once, like some of his posts about that, right? Like that you, in the past, wasn't it something where he had a NuGet package and you would opt into it in your startup or something? Yeah.
Still the same thing. You have to opt in for this specific transport, and you see this is the fastest results we have on plaintext on Tech Emperor for most of the scenarios on Linux. So Stefan Halter took his code and ported it to 3.0. So now it's ready, but ready just soon enough for us to integrate it in the next branch of Tech Emperor, because we merged yesterday. I was about to say a few days ago. I think it's actually.
Do we have results? No run yet, Brian. What's going on?
Takes a few days to run things, and there was already one run. Okay. So if I look at the pull request closed, the top one should be, or it should be about top one. Nope. This one. So yesterday we merged 3.0 previous 7 well, now it will be preview 8 because it's
floating.
Yeah, floating. And so the changes mean that we are using now the 3.0 based Docker images and updating Dapper, updating Entity Framework PostgreSQL. So we also removed DTF8 JSON and span JSON benchmarks because we are using system text JSON now, which is as fast as these guys, so we don't need them anymore. Thank you very much. And updated the database updates to make it also on par with the other benchmarks. I need to find the Docker images to show you. This is a change. Now, instead of using the 2.2 SDK, we are based on the 3.0 SDK, okay, which is go live. That's the idea. And the RTX, HTX benchmarks have been temporarily removed because we're still waiting for the PR from Stefan to be merged, because this is the change to make it compatible with 3.0. Right now, there are too many breaking changes for this DLL to work. So we're waiting for that, and then we'll reintroduce the Red Hat transport for Linux.
Brian says the run completed this morning at 10 a.m.
Oh, with that change?
That's what he says.
Well, that must be the numbers then. Where was I? On this page, take Emperor status. So he said started.
Oh, he says that change wouldn't have made it in.
No, you see, yeah. So the previous run, but the next one.
The next one it'll
will
be in there.
available next. Okay. Yeah. So in a few days. Yeah, I was sure there was one running when I merged. Okay, and yeah, so we should see improved numbers everywhere, so that's why Linux is much faster compared to 2.2 than Windows compared to 2.2. Okay. If I go back on my notes, there is one thing about the .NET consoles I need to mention. I will show you a specific example. Damien mentioned it earlier, which is the endpoint routing. A plain text scenario, which is just the endpoint middleware. There was a dip here, okay? That should go back up tomorrow because it has been merged. And you can see here there is also a jump in terms of memory, and I will take both Linux and Windows. But in terms of memory usage, there is a jump also, committed memory. So there was a change that was more allocated, and you can see it because it's flat, and then we have lots of GCs, and the allocations here was almost nothing to a lot here, and yeah, so that's something we will fix. Yeah, the thing I wanted to show, and actually it doesn't show up here, so I'm concerned that what was allocation rate. No, this here. LOH. You see it's flat. There is no large object heap allocations. And then we have some. Actually, it's not because we have some now that it means we didn't have some before. The .NET counters heap sizes get only updated if there is a garbage collection. And there was not enough memory pressure before to get a garbage collection. Not at all. Okay? Which means the GC heaps here might not be 0, and here what we see in terms of heap for the larger object heap might have been always the same, but it's just that because there was no garbage collection triggered, then we were not updating the larger object heap number. And with this regression, there are some GC which are triggered, and then these numbers get updated. So sometimes the .NET counters can sort of fly but
they're as accurate as they are for what they're measuring, but you need to understand what they're measuring and how they get updated.
And that's super hard. And we discovered that just by looking at the scenario that at some point just went up, and why. And generally, it's just the data that we were sent was not the actual value. That's.
So I'm looking that up. The LOH large object heap, that's 85K.
Yeah.
Size. Yeah. So do you hit that in any of these benchmarks, or is that what you're saying that's something you hit separately?
Well, yeah. So basically, any single object that is over that size will get pushed under the large object heap, which has its own timeline for collection.
And these benchmarks, there's something that stresses that hits.
No. What happened? This is a regression. So. What Seb was saying is that a fix was checked in for a certain behavioral issue, whereby if you were throwing exceptions in your view, like I don't know if you said this, I didn't quite catch it, but all the way back to what caused the issue, if you were to throw an exception from a Razor view, you wouldn't see the error page. right? The diagnostics middleware wasn't catching it, right? Bad, right? Super bad. And so they checked in a fix, and it was to do with asynchrony and exception handling and blah, blah, blah. So they checked in a fix, which was to basically add a finally at the right stage, but that resulted, which basically allocated a new async state machine, the one created for you by the C# compiler and the runtime. And that allocation, even though you weren't throwing an exception, just the allocation of the infrastructure that was put in place to fix this issue, so that if you did throw an exception in a view, it would unwind properly and it would be caught by the developer exception page middleware, that caused this regression. Because just the state machine allocation itself was enough to tip this one over into this regression. So the fix to that went in yesterday, I think, and will be in preview 9. And so they changed how they did it to, rather than allocating a new state machine, they end up adding this thing to be tracked, and there's an event at the end of the request, essentially, where the host will look at things that are registered there and dispose of them or whatever it is you have to do. And so we hook into an existing point to do this cleanup rather than having to build to allocate a new state machine to do it sort of in line in the async call. That's my very rudimentary understanding. But that's how something as simple as someone logging a bug of, I threw an exception in a view and the exception page didn't show. We did the logical fix, which was to, we're not doing the try finally properly around this async thing. And then we did it, and we lost a bunch of performance in this scenario, the endpoint routing scenario, which has nothing to do with view rendering, but because where the fix was put in, it impacted this scenario, and it was all to do with memory. So people often poo-poo benchmarks because they are as sensitive as this. Or because we're working on micro optimizations of what it might be. Well, first of all, these aren't really micro because they're not running in a harness like benchmark.net where we're doing one method a million times, right? We're literally running a full server from another full server through a full networking layer with, this is real load testing, albeit for very specific scenarios. And sometimes a very minute change will regress a specific scenario somewhat significantly. Some of the scenarios are very sensitive to memory allocations because we've done so much work in the framework layer to get that scenario to be non-allocating or low allocating so that there's very little, if any, GC pressure so that your app can use all that overhead and all that processing time instead. So the number might, 4 million requests per second is massive, is ridiculous. Like no real world app is ever going to do that from a server like this, from one server. Although you could argue that if, for certain requests, if you've got caching enabled and it was a simple response and there's no variance from request to request, yeah, you could be getting requests that are doing that if they're served out of memory. But these ones aren't. So all this stuff matters. The reality is that if you did want to do what I just said, if you wanted to have a certain routable endpoint that was highly cached so that for any given 30 seconds you were always returning the same pre-cache response, well, guess what? If the framework is always allocating a buttload of objects and hundreds of objects or whatever it is, every request before you've even had a chance, there is an absolute ceiling as to what you can get with regards to that performance when you do go and do the work in your hot paths to make that really, really fast. And it's not going to be anywhere near what you want it to be if we're already stealing all those CPU cycles and GC cycles for you. So our goal is always to get these things as low as they possibly can be so that you, the app developer, can use those cycles instead of the framework. Now, there are multiple scenarios and multiple benchmarks so that we have the simplest one, the Hello World platform benchmark, all the way through to the Fortunes benchmark, which involves the database server, or the HTTP proxy benchmark, which Seb talked about, which does a different type of outbound traffic using an HTTP client or an HTTP client factory. They're using real types. They're not trying to cheat, but they really are trying to use the primitives that we supply for you in the framework exercised in a simple, isolated way for a specific scenario, and then get that to be as low use as possible. With, hopefully, most of the time, using the standard defaults. You don't have to go in and read a bunch of hacky articles or really low-level stuff to get its performance out. Most of the time, you look at the code and you go, oh, yeah, okay, I can see what they did. Some of them you can see that they're optimized. Like we may have turned a thing off that this scenario doesn't require, and there'd be nothing wrong with you doing that in your app for that endpoint because you don't need that processing. Everything has a cost. Every time you write a line of code, you're paying for it somewhere, whether it's during startup, whether it's during execution, whether it's whatever it might be. And you can always do things in your code to work around those things if it's worthwhile for that particular path. As Nick Graver always likes to say, it's all about trade-offs, and we talked about it last week. Most of our jobs as developers and product owners and managers is about, is this trade-off worth it? You know, what are the three costs and what is it, and the rest of it. So,
but what this is all showing is that a lot of the time you don't think about the performance trade-offs of what you're coding. You think about like, oh, you know, like you're focused on solving a developer scenario. So by having this in your office when you walk in the morning and, you know, in front of everyone, it's something you're tracking.
Yeah, so there's like performance culture, right? So for us, performance is a feature. And when we, it's not just words, like we allocate, we dedicate resources to ensuring that our performance stays steady and continues to improve from release to release. And it's far from free. Like it's a lot of work to do so. And it involves full stack effort from, you know, the teams that run the .NET host in runtime all the way up to the language layer and the framework layer. And it also involves the community. As we know, we've got lots of fantastic help from the community to make stuff fast. Something about performance in this world pushes people's buttons. A lot of people like to hear about it. They like to get involved and they like to see that we're improving for no cost to them. Generally, we make these improvements from release to release, and all you have to do is upgrade and you see that benefit. Now, you might not see a 40% improvement because we got that in plain text, and plain text literally does hello world, but it does mean we got a 40% improvement in request processing if you're just counting the request processing part, right? And so then that is now free for you to use and wherever you're using, but you'll generally lose that performance somewhere else in your app through latency or contention, or you're doing your own memory allocations because you're using objects, because, you know, it's .NET, that's what you do. So often we've seen cases where someone says, oh yeah, I updated from 2.1 to 2.2, some of our first response latency dropped, time to first byte dropped. And people in the real world, they said, I deployed it, I updated my blog from 2.1 to 2.2, and my homepage millisecond response time improved by 30%. And they hadn't done anything. All they did was upgrade the framework, and that's because we had put the effort, and we weren't focusing on their blog. We were focusing on plain text. We were focusing on fortunes, but that transposed directly into people's real-world applications. And it's just a continual rabbit warren, an onion layer peeling exercise. We do this release to release based on the feedback that we get, and we make those trade-offs. Sometimes we can't make the performance improvement we want to because there's a compatibility issue, and we have to either work around a compatibility restraint or look at introducing new APIs to unlock performance that's being, what's the way to say it? Is locked behind legacy, I guess. Some folks are saying in the chat that they lose performance to our business needs. Yeah, like if you do nothing, there's no business need. You can scale infinitely, right? And then every time you add a feature, you're going to give up the performance somewhere, and then you typically choose to come back and revisit those features that you've built that specifically need more performance. The other thing Brian likes to talk about from Tech and Power is that performance these days in the time of the cloud directly translates to money in more than one way. Whether it's you're paying for the CPU time and memory time that your app is using because you're on a serverless infrastructure, or you're on some type of VM or whatever that's billing per CPU cycle, or you are trying to host as many apps as you can inside this few as many resources as you can because they're all costing you money because that's how you pay for stuff in the cloud, or it's because you're like Amazon. What their famous research showed, that for every millisecond of latency that you add to certain rendering, the drop-off rate on conversion is huge, right, and measurable. And so if you want to make stuff faster, there's usually a direct business impact depending on what that type of app is. And even for line of business apps, which I spent a lot of my career building, if you can make the line worker more productive, the person who sits there all day and is doing data entry or using an app that you build in order to do their job, if you can make them more productive and not have to buy a new PC for them, which is a capital cost, or whatever it might be, just by deploying a new update to your app, you're going to generally multiply that by the number of workers you have. So I've worked in companies where we had rooms full of data entry clerks who were taking paper forms and entering them into the system. And you make a change to improve that workflow, and you multiply that by the 30 people sitting in that room doing that work. That's what getting productivity out of computing has always been about, and we're still doing it. This is no different. It's all related. It may be I may be drawing the bow further back depending on what type of industry you work in, but it's you definitely see those results.
So that's a good takeaway. Like some of this is just, it's cool to see, and it's it's interesting for developers. And then another layer to it is like, hey, it's good for us to know that our framework is getting faster. Like pushes me to upgrade. I have a business reason to get on the newer platform and all that. But then another thing is like you're saying, thinking about this all the way through application development as well. And that's that link I shared earlier about the performance recommendation, it includes some stuff in there about monitoring and, you know, things like using mini profiler and dot trace and stuff. So monitor your application regularly and you'll see these areas where you can, you know, the data is in front of you and you're tracking that.
Yeah, absolutely. And to Dane's point, he says the argument I make can go the other way though, and you can sometimes it's just much cheaper to throw a CPU at something to make it faster. I totally agree. I used to joke that maybe we should just put an SSD in every copy of Visual Studio 10 years ago, and that would make everyone's Visual Studio run faster. That is sometimes the right answer. And in the cloud, that can often be the right answer, but it's not free. If you have the money and that's cheaper for you to throw out, and you know that that's your bottleneck, and by throwing more CPU or memory at it, you'll make it faster for your needs, go ahead and do it. If you're selling a framework like we are, we don't have that advantage. We can't do that. You know, we have to.
Well, and you get huge benefits of scale, right? Millions of developers, billions of dollars processed. There's like all these things. So any changes you make, it's a big thing. So, and
so Dane's absolutely right, but it all depends on what you're working on. Kyle asked, we are an hour in, so I'm just going to start answering a few questions.
Bottlenecks, maybe you want to talk about bottlenecks?
We should do that. We should talk about our bottlenecks, and then we can use that to close out. So are there any areas of benchmarks that we're not happy with yet or putting more effort into relative to others towards currently? Yeah, there's a couple. The non-pipeline, so JSON and above. JSON is actually really badly named. So the JSON benchmark here isn't testing JSON performance. It's actually testing... it has a JSON payload. It's a hello world JSON payload. It's very straightforward. But the big difference from plain text is that plain text is pipelined, meaning it sends 16 requests, allows them to process, and then 16 get sent back. Whereas JSON is not. JSON actually, you want me to show something? Yeah. JSON, that's the wrong one. JSON is...
this is JSON versus plain text.
Yeah, so one of those graphs is the plain text test without it being pipelined. The other one is the JSON test. You can see how close they are together. You don't lose much from that benchmark by doing the JSON test, doing the JSON serialization. And so a lot of folks see the JSON number and think, oh, JSON's really, really slow compared to other stuff. So the one thing that we do need to work on is our non-pipelined performance, which as soon as we go from the pipelined test, which is plain text, to JSON, there's a huge drop-off on .NET currently relative to other frameworks. It's an area that we just need to do some work on. Sébastien noted before the Linux-only transport, I think. Did you bring it up? You did. The Red Hat transport, which is not using the .NET sockets layer, and it gets fantastic performance and is much better on the non-pipeline performance than ours. And that's something that we're going to be looking at in the next version of .NET. What can we learn from that? Can we apply that to the generic sockets layer in .NET, which Kestrel then sits on top of? That's not how they've done it. They've literally written a custom Kestrel transport, which you're able to do. We have a libuv transport, which is still available, but we don't use by default. And they wrote a Linux transport that uses its own threads, doesn't use the thread pool, and then p-invokes directly into the Linux I/O stack, networking stack, in order to do that, and it gets much, much better performance. So that's something that we really want to look at. The other one that we're going to continue looking at is Fortunes. Fortunes is the chunkiest test, the biggest one. That's the one that does HTML rendering after reading from a database. We made really good progress on that in 2.1 and 2.2, and we got up into the top 10. But since then, a bunch of the other frameworks have started doing work on their database drivers to support pipelining at the database layer. And that with no change to the application developer. All the update dev does is what they normally do. They just issue their database requests. And then the database driver knows enough about the connection management it's doing and the requests that are coming in that it can choose to pipeline requests over one connection, effectively batching them up to get drastic improvements in throughput. And so we're looking to do that at the ADO.NET layer and starting out with the Postgres driver, because that's what Tech and Power usually runs on Linux, to see if we can get similar gains. So we'd very much like to get our Fortunes benchmark back up into hopefully around the top 5 for Tech and Power soon. So they're two that we're really going to look at next. What are you showing now, Seb?
We have still 1 hour of talking. So
we said 1 hour of talking. We really don't. You have like a minute.
So you know what I want to show, okay? In 1 minute. So here we have a big dip at some point, and we don't know why. We know why, because at that point we tried to install a new network card, but that didn't work. So we put the network card that we had before back, the 10 gigabits network card. And once we put it back, we saw a huge dip in performance. We have never been able to explain that until we arrived a week ago.
Yes.
What happened is that we got the new fast network card that was working, and we installed them on the Windows machine and Linux load, and the perf just went the same, and we're like, what's happening? It's the same.
So to clarify, we had 10 gig network cards, and then we put 40 gigabit network cards in, and it didn't get faster.
Uh-oh.
And then we were like,
So what I discovered is that we had on the client load machine a new kernel different than the other ones. And why is that? Because actually we were running Ubuntu desktop on this machine, which was not only installing new kernels automatically, but also running a GPU driver and Xorg, and that was taking too much CPU. So we were bottlenecked by the client machine on CPU. That's why our machine could not get as fast as TechEmperor is showing on their benchmarks. And also, that's why there used to be a huge dip at the same time we changed the network cards. It's because we got a CVE patch, the same one that, or another one, yes, the same one that TechEmperor patched manually, but we got it automatically because we had
because we didn't know. So this was a confluence of events that happened at the same time, which we didn't know, which meant, well, there's three things. We changed some network cards. We put the old ones back in when it didn't work. Unbeknownst to us, we got a security patch delivered to the client machine that's basically that same day, not knowing. And the only reason that happened was because we were running a version of the OS that we didn't know we were running on that client machine, which also meant that it was running a desktop server with a GPU driver, which we were losing performance to the entire time. And we didn't figure all this out, or Seb didn't figure it all out till last week.
Yeah, everything at the same time last week, because it was like dominoes.
So we've been chasing this phantom 500,000 requests per second, which we thought was that, because the only physical action we performed, the change we knew about was the network card got changed and then put back. And then so we were blaming the network the entire time.
And here we see the red is Windows, the black is Linux, and we changed the two machines at the same time. That's why we thought it was that, but no, it wasn't.
But then it turns out
so we applied the CVE everywhere. We disabled the GPU and everything.
The CVE is the patch.
The patch, the Slack panic attack. And then we got better. And then we installed the actual 40 gigabits card on the Linux machine, and we didn't get faster here. It was like for 2 days. It was not still faster. And we were still CPU bound on the client. And then I looked at the Lua script we were using for pipelining. It happens that it could have been optimized, and I looked at the one from TechEmperor. They changed it to optimize it also.
Oops.
So we optimized it. And at the same time, we had the 40 gigs on the Linux machine, and I updated the Lua script. So now with the 40 gig machine, we can go over what's the client limits.
So now we're going beyond 10 gigabit per second, because we used to be limited by 10 gig, and we thought that was the limit. Then it turned out it was CPU, and that turned out that was because of client desktop and a bunch of other, the CVE. So then we got the 40 gig card in the Linux client server. We've got a 40 gig card in the Linux server, and we fixed the client OS and the GPU stuff and all that crap. And so now we've gone from about 6 million requests per second before all this to 8.3 million requests per second. So now we're able to and we're back to this. Is it the client or the server?
This is what?
So now where is the bottleneck? Do we know? Is it the server?
Yeah.
Okay.
Maybe
so does that match now? Does that mean that we should in the next runs be getting over like on TechEmperor also?
No, because TechEmperor, their environment is lagging us slightly because we provided the hardware for TechEmperor's environment, right? And we have a mirror, but we have been working to get. We knew that the network cards were a limitation, and we've been working this long to try and figure out what do we have to do to get the 40 gig cards working. And so we've only just now got this working, as we just said. And so they don't have 40 gig cards yet. They still only have 10 gig cards.
And
we only have one.
So
two. One in the client, one in the server. So we've got new ones coming, and then we'll get them set up, and then we'll all be able to matchy again.
And 6.5 is our network limit in terms of requests per second.
Yes, because that's a server limit on that one, because that's the Windows server.
But if we had,
this is your final point.
Yeah.
Okay.
If we had 40 gigs everywhere,
right?
I've measured on ULib, Actix, and ASPNET, which these two ones used to be the fastest based on the CV patch or not. We are limited at 6.5. Okay, 6.5. 615. This is the 10 gigabit limits.
Okay.
But if you go to 40 gigabits,
So this is all measured in our environment.
10 millions for ULib, 7 millions for Aptix, and 8 point something. This is the one we have, 8.3 for ASPNET. And if we had 2 clients, because actually at this level we are still limited by the packets per second.
Right.
If we had 2 clients, ULib will be 16 million per second on the same server. So Brian, Nate, ULib is at 16 million and not 7 million actually. And 7 million still for Aptix, so this is really the limit. And same thing for ASPNET on Linux. On Windows, we got 12 million requests per second when we had the 40 gigs with 2 clients.
So there's a bunch of stuff for us to go off and
Yes.
work on. Yeah. Brian, the Lua script tuning isn't in PR because we took yours. We tried to do our own tuning, and then we realized that you'd already done it, and then we took yours, and now we're running the same one as you. It's my understanding. Yeah. So these set of numbers here is just Sébastien went off and did a bunch of investigations with some manual runs to see what can we expect when we start to see these new network cards rolled out across our infrastructure and also Tech Empowers with regards to those frameworks that are currently clustered up the top, all doing about 7 million requests per second. Because we always expected that a few of them, once we take the shackles off the network, would start to stretch ahead again, right? And it turns out that the next limit we turn into, even with a 40 gig card, is likely how much load you can drive from a single client machine. And so then when you add more client machines, which we haven't done multiple client machines with 40 gig NICs yet. But
not 40 gigs. One is 40, one in 10.
Because everything's complicated. It's not just about bandwidth, it's about packets per second. And so the 40 gig cards are different cards to the 10 gig cards. And so they have different chips on them and different optimizations. And so it's not just about getting more bandwidth. Often they're more powerful cards and can do more packets per second. So we're getting there, but things are going to get faster. And we will see new baselines very, very soon. So now we've reset our environment basically to, we've got the security patch installed on all Linux servers. We've got one Linux app server and the Linux load server are running the new 40 gig cards. And then we have more cards coming. We also have new ARM servers coming. And the new ARM servers they will have 10 gig cards. Actually, they're going to have a 50 gig card in them, but let's not go down that rabbit hole. In them, which will run in 10 gig mode. And that will then allow us to free up ports on our switch, and then we're going to be able to pull our switch out to isolate it a little better than it is right now. We're running multiple, effectively, VLANs through the switch right now, which doesn't seem to be impacting the results, but it's just one difference from our setup to the Tech and Power setup, which I don't like. I'd very much like to isolate the traffic through a switch of its own. So we're going to be able to do that once we get the new ARM servers. And I'm very interested to see what performance the new ARM servers get versus the Dell Intel servers that we have in there that are about 18 months to 24 months old, because those new ARM servers are pretty powerful. They're like 30 core or something ridiculous.
Wow.
So anyway, it's a brand new company from Silicon Valley that is building these ARM servers. We're getting a few of those to be able to test .NET Core on ARM. We did do Raspberry Pi a year ago or a year and a half ago, and it was like, I don't know, was it 40,000 requests per second or something on a Raspberry Pi? It's been a while. We should do it again. But yeah, so that's pretty much everything that's coming. And then, we'll have other stuff that we'll do for .NET 5, which we haven't thought about yet, but that's probably a good time to end it.
I think so.
Yeah.
That is amazing.
Back
wow.
to
okay.
there. Well, thanks everybody. If you have any other questions, just reach out to Sébastien or myself or both of us on Twitter. We're always happy to talk about the latest stuff going on in the Smurf Lab and Tech and Power. And we love that so many people love what we're doing on it. Keep watching the Power BI dashboard. You can see what we're doing from week to week. If you think you've seen a regression that we haven't, let us know. Log a bug. We do have a bot that's supposed to log issues for regressions, and it does, right?
Oh yeah, I didn't talk about it, but
that's
we have a bot.
We have a bot that tells us when there's a regression.
Next year.
It logs an issue. And so, but yeah, if you see something or you think we're not looking at an area that's important to you with regards to performance, let us know. Log an issue on the ASPNET Core repo or the .NET Core repo, and we'll have a look at it. But yeah,
very cool.
Thanks everyone.
One last plug as we fade out is it's after the thing ends, it plays a thing and it has a link where you can suggest an upcoming show.
Oh, okay. So after the thing ends, the thing will show you there's another thing you can look at to suggest a new thing.
Exactly.
Right.
I'll put it in the show links too.
All right. Thanks everyone.
Yeah.